Welcome back to Java Internals Crashcasts. I'm your host, Sheila, and today we're diving deeper into the world of locks and conditions. We're currently in our second season, Synchronization Utilities, exploring the chapter on locks and conditions. In our previous episode, we covered the lock interface, and now we're ready to tackle a powerful implementation of that interface, ReentrantLock. Victor, are you ready to unlock the secrets of ReentrantLock?
Absolutely, Sheila. I'm excited to dive into ReentrantLock with you and our listeners. Before we start, I'd like to remind our audience that understanding the basics of threads, synchronization, and the lock interface will be helpful for today's discussion.
Great point, Victor. Now, let's kick things off with a quiz question for our listeners. Here's the question. What key feature of ReentrantLock allows a thread that already holds the lock to acquire it again without blocking? Think about it, and we'll reveal the answer at the end of the episode.
Ooh, that's an intriguing question, Sheila. It touches on a fundamental aspect of ReentrantLock that sets it apart from other synchronization mechanisms. I'm sure our listeners will be pondering this as we discuss the topic.
Indeed, Victor. Now, let's start with the basics. Can you give us a clear definition of ReentrantLock and explain its purpose?
Certainly, Sheila. ReentrantLock is a tool in Java that helps manage access to shared resources when multiple threads are involved. Its primary purpose is to offer more flexible locking capabilities compared to the traditional synchronized keyword in Java. Think of ReentrantLock as an advanced door lock for a room containing shared resources. Unlike a simple lock that just keeps the door shut, ReentrantLock offers features like the ability to check if the door is locked without actually trying to enter, or the option to wait for a specific condition before entering.
That's a helpful analogy, Victor. So, how does ReentrantLock compare to the synchronized keyword that Java developers are often more familiar with?
Great question, Sheila. While both ReentrantLock and the synchronized keyword control access to shared resources, ReentrantLock offers several advantages. First, fairness. ReentrantLock can be configured to use a fair ordering policy, which isn't possible with synchronized. Second, non-blocking lock acquisition. You can attempt to acquire the lock without waiting indefinitely. Third, interruptible lock acquisition. Threads can be interrupted while waiting to acquire the lock. And fourth, condition variables. ReentrantLock allows you to create multiple condition variables, enabling more complex coordination between threads. However, it's worth noting that ReentrantLock requires more explicit coding, as you need to manually acquire and release the lock, typically using a try-finally block.
Those are significant differences, Victor. You mentioned fairness. Could you elaborate on what the fairness policy means in the context of ReentrantLock?
Certainly, Sheila. The fairness policy in ReentrantLock determines the order in which threads acquire the lock when it becomes available. In an unfair lock, which is the default behavior, any thread can acquire the lock as soon as it's released. This can potentially lead to some threads waiting much longer than others if they're consistently unlucky. A fair lock, on the other hand, grants access to the thread that has been waiting the longest when the lock becomes available. While this ensures that all threads eventually get a turn, it can result in lower overall performance due to the extra work of maintaining the queue of waiting threads. You can create a fair ReentrantLock by simply passing true to its constructor when you create it.
That's fascinating, Victor. It seems like choosing between fair and unfair locking involves balancing equal access with performance. Now, let's explore some of the advanced features you mentioned earlier. Can you explain the different lock acquisition methods?
Absolutely, Sheila. ReentrantLock provides three main methods for acquiring the lock. First, we have lock. This method acquires the lock, waiting as long as necessary if the lock is not available. It's similar to entering a synchronized block. Second, there's try-lock. This method attempts to acquire the lock without waiting. It immediately tells you whether it succeeded or not. You can also specify how long it should try before giving up. And third, we have lock interruptibly. This method acquires the lock but allows the thread to be interrupted while waiting. This is useful for scenarios where you want to be able to cancel a long-running operation. Each of these methods offers different behavior in terms of waiting and interruptibility. allowing developers to choose the most appropriate one for their specific needs.
Those options certainly provide a lot of flexibility, Victor. Earlier you mentioned condition variables. How do they work with ReentrantLock, and why are they useful?
Excellent question, Sheila. Condition variables, created by calling the new condition method on a reentrant lock, allow threads to temporarily release the lock and wait for a specific condition to be met before reacquiring the lock. Think of conditions as waiting rooms associated with our lock. Threads can enter these waiting rooms when they can't proceed, and other threads can notify them when it's time to try again. This is particularly useful in situations where threads need to coordinate based on some shared state. For example, in a bounded buffer, producers might wait until the buffer isn't full, while consumers wait until the buffer isn't empty.
That's a great explanation, Victor. Now, I'm curious about potential pitfalls. What are some common mistakes developers might make when using ReentrantLock?
Great point, Sheila. There are indeed a few common pitfalls to watch out for. First, forgetting to release the lock. Unlike synchronized blocks, ReentrantLock requires explicit unlocking. Always use a try-finally block to ensure the lock is released, even if an exception occurs. Second, nested lock acquisition. While ReentrantLock allows reentrant locking, be cautious about acquiring locks in a nested fashion, as it can lead to deadlocks if not managed carefully. Third, using the wrong unlock method. If you use try-lock with a timeout, make sure to check if you actually got the lock before trying to unlock it. Calling unlock on a lock you don't hold will cause an error. And fourth, overuse. While ReentrantLock is powerful, it's also more complex than synchronized. Use it only when you need its advanced features.
Those are crucial points to keep in mind, Victor. As we wrap up, could you share a real-world scenario where ReentrantLock might be particularly useful?
Certainly, Sheila. Imagine a banking application where multiple threads need to access and modify account balances. ReentrantLock could be used to protect these critical sections of code. The try-lock method could be used to avoid deadlocks when transferring money between accounts. If a thread can't immediately acquire locks on both the source and destination accounts, it can release any acquired locks and try again later, preventing potential deadlocks. Additionally, condition variables could be used to implement a notification system for account changes. Threads waiting for an account balance to reach a certain threshold could wait on a condition to be signaled when a deposit is made.
That's an excellent example, Victor. Now let's reveal the answer to our quiz question. The key feature of ReentrantLock that allows a thread that already holds the lock to acquire it again without blocking is its reentrant nature. This is where the reentrant in ReentrantLock comes from. It means that if a thread that already holds the lock tries to acquire it again, it succeeds, keeping track of how many times it's been acquired. The lock is only truly released when the thread has released it as many times as it acquired it.
Exactly right, Sheila. This reentrant property is crucial for preventing deadlocks in certain scenarios and allows for more flexible lock usage patterns.
Thank you, Victor, for this enlightening discussion on ReentrantLock. To summarize the key points for our listeners, ReentrantLock is a flexible alternative to the synchronized keyword, offering features like fairness, timed and interruptible lock acquisition. It supports both fair and unfair locking policies. It provides multiple lock acquisition methods: lock, try-lock, and lock interruptibly. Condition variables allow for complex thread coordination. Always remember to release the lock, typically using a try-finally block. In our next episode, we'll be discussing read-write-lock, another powerful synchronization utility. Don't forget to subscribe to Java Internals Crashcasts and leave us a rating if you're enjoying the series. Until next time, keep coding and stay synchronized.